What we really wanted to achieve here is like, well, why make this really fast car that's crazy fast and everything?
Elon Musk once said Tesla wasn't trying to build better electric cars. He said Tesla was trying to build the fastest cars in the world.
We got to show that an electric car is the best car.
That line wasn't a slogan, it was a challenge. Because if performance truly becomes cheap, an entire industry collapses. And in 2026, Tesla is testing that idea with the Model 2 by combining two things that normally cancel each other out: dual motors and aluminum-ion batteries. If this works, performance stops being exclusive. If it fails, this car never ships. And there's one reason Tesla believes it won't fail. We'll get to that near the end. High performance has always come with hidden costs. More motors mean more weight. More power means faster battery wear. More grip means lower range. More speed means more instability. That's why entry-level cars stay slow on purpose. Not because automakers can't make them fast, but because fast cars age badly when built cheaply. Tesla is trying to break that relationship entirely.
Why two motors change everything, if done correctly. This system is not about raw horsepower. It's about control before chaos. The front motor is tuned for immediate response, producing 155 horsepower and 210 pound-feet of torque, enough to move the car to 60 miles per hour in roughly 6.4 seconds by itself. That matters because launches create the most stress. The rear motor handles a different job entirely, delivering 185 horsepower and 230 pound-feet of torque for overtaking, stability, and mid-range acceleration. Together, they don't fight, they cooperate, and that's where torque vectoring becomes the real story. Torque vectoring doesn't wait for wheels to slip. It acts before instability appears. Power is redirected continuously, millisecond by millisecond, based on steering angle, surface grip, and vehicle yaw. Internal dyno testing shows a 22% improvement in low-speed efficiency during urban driving loops, reducing energy drain by roughly 12 kilowatt-hours per 100 miles compared to single-motor setups. Speed stops stealing range, and stability stops being optional. Wind tunnel simulations, adapted from SAE standards, show lateral sway reduced by 32% during high-speed crosswinds. At 80 miles per hour, the car stays centered instead of drifting. That's the difference between fast and confident.
At this point, most performance stories fall apart because dual motors introduce a problem no marketing department can hide: weight. And this is where Tesla does something competitors can't copy quickly. Dual motors add about 120 pounds. Tesla removes more than that elsewhere. Composite subframes reduce mass by 18%. High-pressure casting cuts motor housing costs by 42% per assembly. Rare earth-free magnets eliminate supply volatility. Condensed power electronics remove roughly $420 per vehicle. This isn't cost-cutting, it's structural subtraction. Manufacturing models still project a starting price around $13,900 through optimized volume production. That number matters, and we'll return to it later.
What this feels like in the real world. In stop-and-go traffic, regenerative braking recovers 32% of kinetic energy, adding roughly 55 miles to projected range. On a skid pad, lateral grip reaches 0.92 G, outperforming similarly priced hybrids by about 22%. Dry surface traction improves by 18% through real-time power redistribution. This car doesn't feel fast for the price. It feels calm under pressure.
The unexpected twist: Senior Mode. This is where the story takes a turn. Tesla added something called Senior Mode. Instead of sharpening launches, torque curves softened by 16%, reducing acceleration shock and minimizing discomfort. Biomechanical studies tied to senior mobility research show a 24% reduction in muscle strain during long highway drives. This becomes the quickest budget EV Tesla has designed, and the smoothest. Performance stops being aggressive, it becomes
accessible.
Why this still makes financial sense. The front motor costs about $1,100 to build. The rear motor costs roughly $1,300. Together, that's $2,400. Comparable high-end systems cost around $5,500. Tesla relies on volume production near 750,000 units annually, supporting margins close to 32% even without tax credits. This performance isn't subsidized, it's industrialized. Everything you've heard so far collapses without one thing: longevity. Because performance that fades is just a gimmick. And this is where aluminum-ion chemistry changes the rules.
Why aluminum-ion batteries matter more than speed. Lab testing shows roughly 25,800 charge cycles with just 7% degradation. That translates to about 3.25 million miles of usable life. Lithium packs often show noticeable degradation after 1,500 cycles. Aluminum-ion keeps going. Energy density reaches 370 watt-hours per kilogram, enabling a 370-mile EPA range in a 330-pound module that's 32% smaller than conventional packs. Smaller batteries need less structure, saving about $220 per vehicle. That's how affordability survives. The battery sustains 330 kilowatts of discharge repeatedly without voltage sag. Internal resistance drops by about 10% compared to standard cells. In extreme heat testing across 9,000 cycles at 120 degrees Fahrenheit, capacity remained at 95%. Lithium analogs fell to 78%. This chemistry doesn't panic.
Why senior mode benefits again. Predictive energy algorithms conserve about 12% more range on long trips. Telematics warn drivers before problems develop. Surveys show 78% of senior drivers prioritize predictability over raw speed. This system delivers both.
The rule Tesla broke. This is why Tesla combined dual motors with aluminum-ion batteries, not to build a fast, cheap car, but to build repeatable performance that doesn't decay, performance that survives years. That's the rule Tesla just challenged. So here's the real debate. If performance becomes durable, affordable, and stable over decades, does the idea of a performance car even mean anything anymore? Or does it force every automaker to rebuild from the ground up? Pick a side in the comments, and if you want more breakdowns that go deeper than hype, subscribe now, because the next teardown exposes what competitors still can't replicate.
Before you go, subscribe, because the next video answers the question this one couldn't. What happens when every automaker tries to copy this, and why most of them will fail? It is going to blow your mind. Brace yourself for next video. Thank you for watching.